Hello, my name is Rick Sato. I am a graduate student who studies computer science at Indiana University, Bloomington. And during this summer, I have worked on automating the cloud deployments of HPCC systems application to AWS with Terraform. So first, I want to talk about what has motivated us to work on this project. Basically, we have been exploring cloud deployments with different various cloud providers, knowing that we have already worked on Azure, and also we have EKS deployments. However, we want to make this simpler because when we are working on this manually, those deployments can take a long time. And it can be hectic because you have to execute a sequence of command in the exact order that we need to do. But with Terraform, because it's an infrastructure as a code, we can code our infrastructures as resource blocks and hit Terraform apply. We'll just have to wait. So this consistency is what Terraform has brought us in terms of easing up the burden on us developers for the deployment. And we have worked on the AWS because Mr. Gaji has already integrated Terraform into Azure and also HPCC systems deployment. So we thought of, okay, let's do AWS. In terms of designs, we have committed to making this simple. So we have one VPC, AWS VPC, and inside we have created a public subnet and the private subnet, and we're deploying our application into this private subnet. So the difference between the Azure and AWS, I realized this is a learning moment, is that subnet is associated with specific availability zones. So there you can span a subnet into a different availability zones. But then in Azure, I realized that I haven't coded in Azure, but what it looks like is that Azure does not have this notion of availability zones. And there are some other differences that I realized that's really interesting in comparison. So that's why I put that diagram there. And another notion, an important thing that Terraform offers is this reusability, increase of reusability by employing the modularization. What this is that when we're coding, we could code everything into one file, which is not a good practice in most of the cases, but we could, so we could do that. But what we also can do is that we can put specific set of resources that goes together to create VPC, EKS, and EFS, and the Kubernetes into different directory and call it a module. What this does is that we can reuse these components in any other scenarios. We can call that specific module to create something else. So this modularization actually increases our reusability of the code. And it makes things so much simpler because we can pass all these values and variables between them. And also we can specifically ask to create this set of resources after one another by specifying dependencies between modules or between the resources. So what we have realized during this internship is that deployment, as I was developing all these code, was not as easy as I thought. We have faced some challenges, especially working on EFS, particularly EFS driver installation was very challenging. We have been able to figure out thanks to help from Ryan's team, who is another intern, and we have also integrated their work. And also, the Helm chart seems to be a bit of a challenge when we're trying to deploy, but we have been able to address that issue. And at the end, we'll be able to offer you a complete and easy deployment of our application, HPCC systems application, to AWS EKS with one single click, Terraform apply. And that GitHub repo is going to be public soon. So thank you so much for watching, and I would like to thank my internship supervisor, Mr. Wayne, and Mr. Gaji for guiding me through it. I really appreciate their support. Thank you so much.